Elon Musk's rocket hit the moon. Photos show the impact. This image comes from South Korea's lunar orbiting probe Danuri, also known as Danuri. Compare pre-impact left to post-impact right. See new changes in the white circle. Dark region forms with ejecta spread out. This is the result of a 4-ton rocket hitting the moon at 8,700 km/h. Why did the rocket hit the moon, and what does it mean? Skygazer Layashi Zai here. The moon-colliding rocket wasn't functional. It was actually the discarded second stage of a Falcon 9 rocket. It's not a full rocket, but the discarded second stage of a Falcon 9. Upper stage rocket, 14M long 4T Jan 2025 launch. A Falcon 9 will launch 2 lunar landers into space. One of them is the Blue Ghost one from Firefly Aerospace, which successfully landed on the moon's surface later. The Resilience lander by A-Space failed to land successfully. Falcon 9's second stage separates from lunar landers. Mission requires long orbit trip. Rocket runs out of fuel. Economic orbits return controlled post-mission. It stayed in high orbit for over a year, solar and lunar forces altering its path. Eventually, it entered a trajectory destined to collide with the moon. On August 5, 2026, 2:34 p.m., the rocket hit 2.4 km/s. Speed 8,690 km/h crash on moon. The predicted impact site was located between the Bell and Einstein craters, near the edge of the moon visible from Earth. I hope everyone understands this wasn't a deliberate moon crash by Musk. SpaceX left a used rocket in cislunar space, not aimed at the moon. Gravitational forces and solar activity caused changes. It accidentally collided with the moon. Scientists merely tracked it ahead of time. Predicted impact time and location, attracting astronomers. Telescopes, including an 8-meter VLT, pointed at the moon before the collision. Unfortunately, we didn't capture any high-definition video of the rocket impacting the lunar surface as imagined. A key reason: poor impact site near the visible lunar edge. We see the impact area from the side. It hit the sunlit moon surface. Observing the brief, bright lunar impact from Earth is incredibly challenging. Currently, most high-definition videos seen on social media platforms are generated by AI. 90% AI generated, 10% pre-impact, no collision moment. After impact, VLT detected sodium and lithium for 5 to 10 minutes. These elements likely originated from lunar material that was vaporized and scattered due to the high-speed impact. Lithium may have come from the rocket. South Korea's Danuri gave more direct evidence. It began filming this area about 30 minutes before the collision, and then adjusted its orbit multiple times, passing over the impact site 8 times in total, thus providing us not just a post-impact image. Clear photos show pre- and post-collision comparisons. Terrain changed, ejecta traces remain. This Falcon 9 upper stage indeed left its mark on the moon's surface. However, the resolution of these current photos. Impact crater size estimated at up to 27 meters, precise measurement pending. How much do the results differ from the calculations? The next most anticipated development is NASA's Lunar Reconnaissance Orbiter, LRO. LRO photos may show crater shape, size, and ejecta. At that time, I will provide you all with a detailed analysis. Don't forget to subscribe to this channel. So what can this unexpected collision offer us? First, rare impact test shows lunar craters. It's a rare controlled impact test. Moon surfaces show many craters. Impact origins are lost, making accurate weight and speed guesses impossible. This time differs. Scientists estimate this rocket's impact energy easily due to known size, structure, and velocity. Measure crater size, compare to models. This helps scientists understand lunar crater size from impacts. Second, the element rain and ejecta produced by the collision allow us to study lunar surface materials. High-speed impacts propel rocks and dust from the lunar surface into the air. By analyzing these materials, studying lunar chemistry and low-gravity vacuum behaviors. Third, this event also validates humanity's ability to track objects in cislunar space, understand impact areas' chemistry, and lunar material movement in low-gravity vacuum. Event confirmed human tracking skills in Earth-Moon space. This rocket has been drifting in space for more than a year. Scientists re-identified it, predicting lunar impact. Future growth in lunar orbit and surface tech increases importance. Rocket debris could hit target, low likelihood. However, if such an impact were to occur, it would be capable of causing severe damage to nearby equipment. This time it struck an uninhabited Earth, an uninhabited lunar surface. Moon visits rise, space debris must be managed. Well, what do you think about this? Don't forget to like, follow, and comment. See you next time.